Hi, good evening, everybody. It's 6 o'clock. I'm Carol Willis. I'm the director of the Skyscraper Museum, and I'm delighted to join you tonight, even with my very hoarse voice. I hope I'll make it through the whole evening. But I this gives me the opportunity to give Tom Leslie, our speaker tonight, as much time as he needs of our usual hour in order to explore this new book, the second of two on Chicago skyscrapers. The first he spoke about at the Skyscraper Museum about 10 years ago, and that was really about the first time that I met Tom. But he's been a wonderful friend to the Skyscraper Museum. He's been a great colleague and collaborator. He's been central to several of the semester-long studies that we've done on questioning the history of the earliest histories of the skyscraper, in a special series on construction history, work in progress, that compared New York and Chicago, which he co-curated in effect with our friend Don Friedman as a New York specialist. But Tom is Mr. Chicago extraordinaire. These two books on the Chicago skyscraper, covering from the very first years in the 1870s, and now more than 100 years to the framing of the end of this book in 1986, does leave Tom some territory still to cover. But in these two volumes, we see an extraordinary holistic view of the development, not just of the high rise, but of the city of Chicago as an urban place. And it's in the new book, the extension beyond the borders into the suburbs, and the effect of the architectural culture of of Chicago on the outskirts of the suburban areas. So Tom's holistic view, which is well summarized in the subtitle of this book, How Technology, Politics, Finance, and Race Reshaped the City, brings many lenses to the analysis of architecture in Chicago. But tonight we asked him to talk specifically about residential architecture and some of the lesser known buildings, the kind of second tier firms, but in the context of this kind of second Chicago school under the influence of Mies and others, and Fazler Khan and SOM. So that is what he's going to do. And this follows in the kind of double duty of tonight's talk as one of the series in the lectures and ultimately the exhibition that we'll do at the Skyscraper Museum with Tom as a guest curator on the modern concrete skyscraper. So we began with Chicago in a talk that Tom did with Bill Baker. Actually, we began with Marina City, that will be recalled again today. And we looked also at Europe, we looked at New York, and now coming back to Chicago to take this lens of the material of concrete and to feature that as a continuity in the Chicago tradition, which Tom will do tonight. And Tom, you're going to do it quickly because my voice is now failing. I'm going to let you come onto the screen, show the two covers of your books, and exit myself.
Thank you so much for that introduction and for soldiering on despite the hoarseness. It's always a pleasure to speak at a Skyscraper Museum event, and tonight is no exception. This project that Carol and I have been discussing to look at the history of the modern concrete skyscraper is one that I think is really important, particularly as it relates to Chicago, because we think of Chicago as a steel city, and we think of its skyscrapers as a story about steel. But in fact, as I hope to show, concrete plays a huge role too. The mythology of post-war Chicago is really that we owe so much to Mies van der Rohe and these two apartment towers, 860, 880 Lakeshore Drive, which even today are some of the most popular destinations on the architectural tour of the city. Mies, of course, had both disciples and followers, and we often think of the work done at SOM as following in those footsteps. And then these figures like Bertrand Goldberg and projects like Marina City that we almost in traditional histories see as like apostates, like turning away from the sort of Miesian tradition. And there's a grain of truth to that. Mies was profoundly influential in this city, and those two buildings have certainly influenced the way that architects here have practiced, and indeed architects around the globe have practiced. But they are also, as I want to show, anomalies. We don't typically build apartment buildings or residential towers out of steel. We build them out of concrete. And that's one of the things I want to touch on in this talk. But I also want to show how these two towers, these famous towers, were anomalies in other ways as well. And while they may have been influential architecturally, they were maybe less influential tectonically or technically. This story is going to look at some familiar buildings by architects who maybe are less familiar. Lake Point Tower by Schuppert and Heinrich, for instance. We'll look at some buildings that are by familiar architects, but have not really entered the canon for one reason or another. This is the so-called hidden Mies van der Rohe up in Lincoln Park. And then finally, I want to show some buildings by architects who aren't known, who I think should be part of the canon, who designed and built primarily in concrete, and who really did help shape Chicago's skyline in ways that have never really been fully appreciated. And one thing I want to stress is that when we think about the classic post-war Chicago skyscrapers, there are maybe 3 or 4 dozen in the loop, many of them of steel, some of them of concrete. But those were just a small percentage of the actual skyscrapers that were built in the city. Of the roughly 300 or so towers that were more than 15 stories, only a few dozen of them were commercial downtown, and the vast majority of them were concrete residential structures that were built elsewhere in the city. So there are really two streams that kind of come together in the way Chicago approached residential concrete in the post-war era. One is that the city did have a tradition of building in concrete, and particularly of being, if not a pioneer, at least an early adopter of a system called flat plate construction. Here are two buildings from the 1910s, the Dwight Building, which is sort of well known by Richard Schmidt on Printers Row, and another building long since gone from the West Loop called the Sharples Building that was built in 1912, a more generic combination industrial and commercial building. These projects both used a system called flat plate, where the beams and girders that you would traditionally find in concrete construction at that point were dispensed with in favor of heavily reinforced, fairly thick, but nevertheless thinner than the beams and girders in frame construction, concrete slabs. You can see in the construction photo of the Sharples that the columns are very thick, very heavy. They hold up concrete slabs that are about 10 or 11 inches thick. And that thickness allows the concrete to span a reasonable distance, maybe 20 to 25 feet, as opposed to the 35 to 40 that steel could span. But it does so with less depth. In other words, a steel structure or a concrete frame that had to span that would be deeper, and that would get in the way of machinery, and eventually, as we'll see, in the way of mechanical systems. The other strand that I want to bring in is Chicago's housing history. And from a very, very early point, concrete proved to be a good match for Chicago's housing needs, whether it was kind of middle-class housing like the Michigan Avenue Garden Apartments, this fairly well-known experiment in public-private housing in Bronzeville from the late 20s, or whether it was more luxury housing like the Powhatan Apartments, Robert de Goyler, one of the great sort of 1920s, 30s era Art Deco and neoclassical architects of Chicago's apartment towers. who used concrete and particularly flat plate to squeeze as many lettable floors into his designs as possible. And finally, I want to look at one figure who's an important transitional figure between the pre-war and post-war eras, and that's Henry K. Holtzman. Holtzman was trained as an architect, but had a brief flirtation with the automotive industry. The Holtzman Automotive Company lasted only a few years in the early parts of the 20th century. But when Holtzman returned to architecture, he came back with a real sensibility about automotive engineering and wanting to apply the efficiencies, and particularly the sort of assembly line efficiencies that he had seen beginning to grow in the automotive industries, to residential construction. In the early 1940s, the Chicago Housing Authority hired him to design the Cabrini row homes. These were remarkably successful 5-story buildings that housed elderly people on the ground floor and then families on the upper 4 floors, divided into 2 flats of 2 stories each. Holtzman was able to apply all sorts of new concrete technology to these, and again, to squeeze in as many floors as he could in this relatively short stack that he had, or short height that he had to work with. CHA really learned from these, and a lot of the early Chicago Housing Authority projects, in particular Dearborn Homes, which still exist on the South Side, borrowed some of these techniques. So borrowed in particular flat plate concrete construction to get many floors within a fairly limited height. The Dearborn Homes also pioneered ideas about family living. So there were spaces for children to play on each floor. And concrete allowed flexibility in planning that steel would not have for these early CHA projects. Holtzman, however, went on to find a sort of middle ground. He took in particular the ideas behind concrete forming that he'd pioneered in some of these earlier buildings and put them to use in a series of low and mid-rise co-ops throughout the city. They're kind of recognizable by a handful of sort of stylistic tics. Holtzman loved the kind of curved brick wall and the kind of jutting bay window. So in projects like the Lunt Lake apartments on the North Shore, or Winchester Hood that you see here, or Parkway Gardens on the South Side, Holtzman was able to take ideas about concrete construction like prefabrication, some sort of rudimentary post-tensioning, reusable formwork, and apply them to middle-class housing throughout the city. None of these are high-rises, but you can see in this article from American Builder that Holtzman is looking to kind of find any efficiency he can, both in the labor and in the material. So trying to make the floor-to-floor heights as small as possible so that he can spend as little as possible on cladding. Trying to find ways to prefabricate formwork, for instance, so that it arrives on site ready to go. You see in the center there some sort of early versions of pan joist systems, and also finding ways to make planning more efficient so that more units could be packed into smaller and smaller areas. Holtzman is important also because of who he hired. A young intern in his office about this time in the late 1940s named Herbert Greenwald would go out on his own and later would hire Holtzman back when, in the late 1940s, he found a plot of land in Hyde Park on Lakeshore Drive that he thought would make a suitable spot for high-rise apartments for University of Chicago faculty. Legend has it that he contacted Frank Lloyd Wright and Eero Saarinen and Walter Gropius, all of whom turned him down. But Greenwald then contacted Mies van der Rohe, who at the time had never built a high-rise building. And Mies came on board as the design architect, but in conjunction with 2 other firms, Pace Architects, who were a group of Halliburton Root alumni who were very good at construction drawings, and Holtzman's firm, both for its expertise in setting up the co-op, the corporation that would run the development, but also for his expertise in building efficiency and construction efficiency. And when a couple of students and I sort of unpacked the promontory construction and looked in detail at both how it was built and how Holtzman's ideas about concrete formwork might have transferred from the low-rise projects he was doing in the 40s into this high-rise. It's pretty convincing, I think, that Holtzman was behind a lot of the sort of tectonics of Promontory, that it's an exposed concrete frame, plain building in Mies's words, but also building that doesn't require additional cladding. It is, as you can see, a pan joist system, a system that Holtzman was very familiar with. And it was very repetitive. The formwork could be used again and again and again by a relatively small labor crew who could pour one floor, wait for that to cure, and then take the forms and move them up 3 or 4 floors to another floor under construction a week or two later. You can see too that this often gets referred to as it's like Mies's starter high rise. It's an exposed concrete frame, and it doesn't have the floor to ceiling glass that 860, 880 Lakeshore Drive had. That was largely an artifact of Chicago's code at the time, which required a 3-foot high spandrel panel to prevent fire from going from floor to floor. It was part of what Chicago was part of Chicago's code known as a prescriptive code. In other words, it told architects exactly how their buildings had to be configured. Even as Promontory was being completed, however, the city was going toward a more liberal performance code that opened up the possibilities for different fire suppression techniques and would eventually allow the floor-to-ceiling glass that we're more familiar with in high rises today. There's also evidence that Mies was quite happy with this formula because he and Holtzman and Pace worked on other projects that literally repeated the same formula again and again. The Algonquin Apartments, a set of 6 towers that are just north of Promontory, a project that Mies later disowned for reasons that involved adding apartments to the ground floor late in the day. Nevertheless, these are reasonably sophisticated designs, and they borrowed both Holtzman's skill at concrete construction and his skill at putting cooperative agreements together. If you compare this construction photograph on the left with the construction photograph of the Sharples building, you can see that it is still flat plate construction, that it's basically borrowed the techniques that were used in industrial loft buildings in the West Loop and Printers Row in the 1910s, and basically now expresses them, right? Puts them on the facade, treats them as kind of as-found aesthetics that Mies was quite happy with, right? Mies thought that exposing the industrial nature of construction was just fine, and in fact was a way to create buildings that talked about their construction and their technology in a fairly natural way. Chicago's more liberal code was passed at the end of 1949, and very quickly Mies's formula changed. Here at 2933 Sheridan, the kind of hidden Mies building, the one that rarely gets talked about, you can see that Mies still has the concrete flat slab, still has the exposed frame or the expressed frame, but now instead of the brick sill, the glass goes from floor to ceiling. And this was a major selling point in the architecture. This again is a Herbert Greenwald developed building. This is his brochure. That is clearly not a Mies perspective on the right, but you can see that the floor to ceiling glass and the flat slab construction, the exposed flat slab ceiling, are both elements of the project that are signature elements, and also elements that will come back again in later Mies van der Rohe apartment buildings, but also in other high-rise residential. The exposed frame also became a sort of trope in public housing, and SOM's built project for Ogden Courts, basically, by their own admission, was taking Mies's Promontory model and repeating it for public housing, for affordable housing in the city. Ogden Courts were one of several projects that progressive architecture in 1951 really gave Chicago credit for leading the way in literally progressive housing projects, trying to combine the latest technology, the latest ideas about architectural development into housing for, in particular, the residents who had come in the Great Migration and who were forming really the bulk of the problem, the housing problem for Chicago. Ogden Courts, as you can see, had an exposed frame, brick sills that were more about saving money than they were about fire resistance. But you can see that the promontory model here is very clear, that the concrete is exposed, it's allowed to sort of speak plainly for itself, and it's repetitive. The formwork was used over and over again to build Ogden Courts. So chronologically, this is when 860-880 Lakeshore Drive comes in. And looking at these buildings, I think we can see in this context that they are really anomalies, that they're unusual. They use steel for their framing, steel decking for the flooring, concrete floors, but not the flat plate construction that we saw. Instead, the concrete is combined with steel reinforcing and supported on steel beams and girders. The cladding is also steel. That's an anomaly. That's a slightly different story. Aluminum cladding was just coming online and would really form the bulk of high-rise curtain walls throughout the late 1950s. So 860-880, even though they're phenomenally important as works of architecture, don't really fit in the story of residential construction in Chicago or elsewhere. We build residences out of concrete. And even at about the same time that the 860-880 were receiving the most excited press, Architectural Forum runs an article on Chicago architecture. They find 8 apartment buildings, and they pick a couple of Mies buildings, but they're concrete Mies buildings. They're dorms at IIT, and they're a project that we'll look at here in just a second, 900, 910, the buildings that are across from 860-880, and that really show the change in Mies's office and his sensibility about what really made for appropriate technology for residential construction. A couple of the projects that Architectural Forum looked at were also key in advancing the agenda for housing in Chicago, particularly advancing middle-class housing in, or I should say near or within walking or driving distance of the Loop. One of the most important of these, and one that I think is really overlooked a lot in the history of the city's high-rises, is Lake Meadows. Lake Meadows was a so-called urban renewal project that was designed to replace what was considered slum housing, and which was really inadequate, often unhealthy housing in part of Bronzeville that had been taken over in large part by absentee landlords, largely white landlords from elsewhere in the city, and allowed to decay even as those landlords sort of jacked up the rents. Lake Meadows was a joint venture between the city and New York Life to replace about 4,000 apartments with new modern housing that would be geared more toward the middle class. And concrete played a huge role both in its initial conception and in its eventual realization. The first Lake Meadows project, designed by a figure at SOM named Ambrose Richardson, would have been the closest thing Chicago came to a genuine Corbusian unité. 2 giant 600-foot-long slabs made of concrete, a very, very thin plan so that cross ventilation would go through, and with corridors that were outside, that were seen as galleries that would function as both circulation and also play space for children and families, big enough to, say, have a barbecue or to set up a small swing set. Ultimately, New York Life balked at this. They wanted a more phased approach that would allow them to build 1 or 2 units and see if they worked first. And what was eventually built were these 4 concrete towers with glass and steel curtain walls that used flat plate construction to achieve the maximum number of floors within an affordable height. Lake Meadows was also integrated. It was designed primarily to house Black families on the South Side, but it was also a successful project from the city's point of view in that it attracted white residents as well, something that the city was sort of desperate to achieve in the 1950s. This image on the right is actually from Ebony magazine that talked about the provision of new modern apartment buildings in Bronzeville as something both progressive from a housing policy point of view, but also from a technical point of view. And they made a big deal of the fact that the concrete construction made it easy to clean, easy to heat and cool, and that the provision of these kind of technically modern buildings showed that Chicago was serious about addressing some of its housing problems. The legacy of 86880 is interesting in other ways, though, in particular in the sort of competition that it inspired. And one building in particular that showed both what concrete could do and also ways in which 86880 were sort of dead ends in other technical ways as well was 320 Oakdale Avenue, again in Lincoln Park, by an architect named Milton Schwartz. Schwartz was the son of a heating and cooling engineer. The Schwartz brothers had a contracting practice, a heating and plumbing contracting practice. And Schwartz had his eyes set on a piece of land across from his apartment in Lincoln Park that he convinced his uncle and his father to sort of go in on him with. 320 Oakdale was designed to be sort of middle-class housing. It was designed for families. But Schwartz saw in 86880 a couple of shortcomings that he thought could be solved, both with concrete and with the technology that his father and uncle were working with. So here you can see the building today. The concrete structure allowed for both these cantilevered sunshades that stick out on all four sides, which technically isn't exactly right, but certainly gives the building some shade from the south summer sun at least. But it also allowed the building to tuck in at the base. And this then permitted a driveway to go around the main entry lobby. One of the first buildings in Chicago to really acknowledge the importance of the automobile in the post-war era. The concrete structure allows the cantilevers, it allows these transfer systems. But maybe more important was the way that the building was sold. Here you can see that Commonwealth Edison, the utility in Chicago, is actually treating the building as an example of where it sees its market going, because it's showing you that the building is the first all-glass, fully air-conditioned building in Chicago. 2933 Lakeview, the concrete Mies building was not originally air-conditioned. 86880 Lakeshore Drive notoriously wasn't provided with air conditioning. 320 Oakdale was. And I think that it really set the tone for the next generation of high-rises in Chicago. Here from the sales brochure, you can see that it's advertised as being cool, completely air-conditioned, all-glass, multi-story apartment building, Chicago's first, and new, that the concrete structure allows for these cantilevered sunshades that help keep the building cool in the summer, but also that give it its distinctive profile on the skyline in Lincoln Park. How influential is 320 Oakdale? Well, just as it was finishing up, Mies and Herbert Greenwald embarked on their next pair of projects. The Esplanade Apartments right across the street from 86880 Lakeshore and Commonwealth, which were just a couple blocks from 320 Oakdale. And these buildings all took advantage of flat plate concrete construction. They all also featured integrated air conditioning. And as you can see here from the construction photo at Esplanade, they featured aluminum, prefabricated aluminum cladding. So in just a few years, right, 86880 is done in 1951, 1952. A year or two later, after the competition sort of shows its hand at 320 Oakdale, Mies and Herbert Greenwald and a new architectural firm, Hokamp had gone bankrupt in the meantime. Friedman, Altshuler, and Sincere took a lot of the ideas that Greenwald had absorbed about trying to model the automotive industry and put them into use here with prefabricated cladding panels integrated mechanical systems. And the flat plate was really a key part of that. If you look at the plans, very famously show on the left the difference between the steel construction at 880 Lakeshore and the concrete construction at 900, 910. And you can see that the plumbing for the air conditioner sort of pushes the curtain wall out from the structure, makes it into a maybe less architecturally rich curtain wall, but one that technically I would argue is a little bit more advanced in how it integrates mechanical and structural and cladding functions. Steel columns tend to be smaller than concrete. Steel is stronger than concrete. And you would think that that would lead you to consider steel as a material for apartments. What you rarely see, however, is the section of 860 compared with the section of 900, 910. Steel gets its strength from depth, from being able to take a very small amount of steel and stretch it out in section into an I-beam. It resists bending basically by putting as much depth between the top and bottom flange as possible. At 860, 880, that led to a floor depth of 20 inches. In commercial construction, that's not a problem. We have to weave ductwork through the structure to get air conditioning to various offices. And so we can use that 20-inch depth. We can cut holes in the web of the steel beam to get ductwork where it needs to go. In residential construction, particularly if we're getting air conditioning and heating through plumbing, through moving water through the building, we don't need ductwork. And you can see here in the comparative section that 900, 910 uses a 10-inch floor slab, a 10-inch thick concrete floor slab, in place of the 20-inch deep steel and concrete that goes to the floor construction at 860, 880. Greenwald also kind of turned the thumb screws a little bit on the floor to ceiling height. It's 4 inches shorter at 900 than it is at 860. But you can see that there's a tremendous savings in the depth of the floor itself, that they save 10 inches out of every floor by switching from deep steel to relatively shallow concrete. The concrete plate is heavy, so it needs the bigger columns. There's a space penalty to pay there. But 900, 910 is shorter than 860, 880 Lakeshore Drive, and it has 2 additional stories. So that's 2 more floors that originally could be rented out. And this less cladding, less elevatoring, less stairs, right? There's less material in 900, 910 in terms of its cladding and all the vertical risers, but there are more units. And this really is the reason that we use flat plate construction wherever we can in residential, that it's the most efficient sectional way to put as many floors on top of one another in a given height. No other major steel residential high-rises were built in the post-war era in Chicago after 860. And if 320 Oakdale hadn't been proof of concept enough, the buildings at 900, 910 and at Commonwealth Promenade both sort of sealed the deal. And concrete became the material of choice for every residential high-rise in Chicago afterwards. The other thing that happens around the same time is that Chicago's approach to housing changes. And it changes with a new mayor, Richard J. Daley, who takes office in 1955 and has a real vision for revitalizing the loop that's going to involve trying to convince the middle class not only to stay in the city, but to provide for middle-class housing within walking distance of the loop. The same idea behind Lake Meadows, but with the Daley administration, they are going to accelerate that and try to make it so that corporations want to stay downtown because they have a natural kind of population at all kind of levels, that their secretaries can live near downtown, their managers can live near downtown, and even their executives can live downtown. The so-called Central Area Plan, which is Daley's plan for kind of revitalizing and nourishing the loop, has housing as one of its main goals. And throughout the kind of orbit of the loop, you see in the early 1960s and beyond, a lot of projects that I think can rightly be called Daley projects. The greatest of these is Marina City. This is the kind of original proof of concept, if you will, of Daley's idea. It's literally right across the river from the loop. And concrete plays a really key role in its construction. Bertrand Goldberg, the architect, as you may have heard in Jeff Goldberg's talk a few months ago, had a vision for Marina City being literally a city within a city. So commercial activity, residential activity, entertainment activity, all going on within the same complex. His idea about the towers was part structural, that the cylindrical tube is an ideal structural form, but also partly constructional. If you look at the construction photos, you can see that there are what we call slip forms today. These are forms that literally travel up the cores, pouring a little bit of the core at a time. And as those cores strengthen and cure, the form relies on those to sort of jack itself up and pour more core as it goes. This is a technology that's borrowed from grain elevator construction, something that was pioneered in Chicago. And it becomes very quickly the standard technique for pouring concrete cores in particular in skyscrapers. The other kind of big advance here is that the contractors, McHugh Construction, developed fiberglass forms to achieve the complex curving shapes, especially of the balconies. And they did this by building the balcony in timber one time, using that to create a number of fiberglass forms that they could then use over and over again. So advancing not only the structural potential of concrete by thinking about it as a tube shape, but also advancing the construction aspect of it by repeating the same form again and again and bringing mass production in a way into the construction of these towers. Here you can see a little bit more detail on the construction. Again, this is a model by these two students who work from original drawings so that we can sort of investigate and find out what's behind the skin in some of these towers. And you can see the curving beams that support the balconies that were only possible with this fiberglass construction that McHugh was able to put together. There was also a major development in the financing that took place at Marina City. The lead developer was a janitors union downtown who had interests, of course, in the loop staying populated so that their union members continued to have work. But it was also the first high-rise to enjoy federal housing authority mortgage protection. In 1961, Daley and several of his administration went to Washington to convince the new Kennedy administration to open up the mortgage insurance program that FHA had put together to that point only for single-family dwellings. FHA was convinced that high-rise housing was a solution to the crisis in America's cities. And Marina City was the first to have its mortgage backed by federal protection, which enabled the developers to get lower interest rates and therefore really enabled the construction itself. Because it was FHA insured, Marina City had to be integrated. It would have been anyway. The janitors union was an integrated union, but Marina City was one of the earliest projects within walking distance of the loop to accept both white and black tenants. And again, here you can see Ebony, which a few years earlier had talked about Lake Meadows as this marriage of technology and housing policy. And here, talking about Marina City, it does the same thing. It says, here is the space age building that uses advanced concrete techniques, and it is an integrated project, right? This is something that, again, shows that Chicago is trying, even if not maybe up to the task altogether. Chicago is using the latest in technology, the latest in concrete technology to help address its housing issues. That progressive spirit wasn't the same everywhere. And at the same time that Marina City was putting private and public money together, Chicago's public housing was going through a real crisis. The early successes that we saw at places like Ogden Courts or Dearborn Homes were challenged by increasingly tight budgets, an increasingly conservative federal government that was giving less and less money to public housing projects, but also by attitudes in the city itself. public housing could be vetoed by any ward alderman, and it was therefore squeezed into very tight sites instead of being distributed throughout the city. There was, in the words of one-time CHA Chairman Elizabeth Wood, nowhere to go but up. And even though Wood and others thought that the high-rise was inappropriate for the families that CHA was having to house, high-rises went up in public housing projects throughout the 50s and 60s in Chicago. Concrete here played a very different role. Whereas in Marina City, it was seen as progressive. In the public housing projects, it was often seen as cheap or sterile or industrial. Some of that was due to the quality of other finishes in the projects, which had to be sort of bottom of the barrel cheap and therefore deteriorated really quickly. But at the same time that concrete is getting a kind of positive rep from projects like Marina City, it also comes to symbolize the failures of public housing in Chicago, with one key exception. And that is a project that Bertrand Goldberg took on shortly after Marina City for the Hilliard homes on Cermak on the south side. Goldberg applied a lot of the same ideas about mixed use and about trying to create a kind of lively city within a city. A lot of those ideas were brought to him by sociologists that he hired. A lot were brought to him by potential tenants who he invited into his office to lay out apartments. The concrete structure that he used, again, used slip form to build these sort of extruded structures that rose out of the ground, very much like the grain silos, climbing one story at a time. And also relied on, as you can see, bearing walls, right? Returning the function of structure to the exterior wall, the opposite of the advances in curtain walls, lightweight skins that don't contribute to the structure of a building. Here, Goldberg realized that the one way to save money would be to go back to the idea of the structure and the skin being the same, and to use concrete as an exterior wall that would not only keep the rain out, but that would also actually structure the building, that would hold it up. So on the left, this is actual construction photos showing the slip forms kind of extruding the same plan over and over as they go up. And on the right, you can see, very much like Marina City, Goldberg using the plasticity of concrete, its ability to take a variety of forms to shape the units in the Hilliard homes to the kind of programs that he derived from interviewing the tenants themselves. The idea of concrete as a bearing wall comes back in other places as well. There's a kind of innovation that happens first in New York. I have to admit that this is that New York takes the lead in this, where I.M. Pei and the engineer August Commandant develop what they call mullion structures for the Kips Bay apartments on the east side. These, as you can see from the image in the upper right and the construction photo in the lower right, basically melded the idea of the mullion and the column into one thing, taking the idea of using the skin of the building as the structure in addition to the enclosure, but distilling that structure down into heavily reinforced, relatively thin concrete members that are somewhere between a window mullion and a concrete structure in scale. They hold the glass windows in, but they also hold the edge of the floor plate up. There was one of these that was designed by Pei that was built in Chicago. University Apartments, which you see on the left, done in 1961, used precisely this mullion structure to support the building's floors. One of the residents of University Apartments was the engineer Fazler Khan, who was working for SOM and was beginning to develop the idea of the tube structure. A tube structure is basically a mullion structure like Kips Bay, but where all of the exterior walls are working together, basically making the building into a giant hollow column. By pushing all of the structure to the exterior skin of the building, the structure not only resists gravity very well, but it's also very efficient against wind. If you think about taking a paper towel tube, you can stack a book or two on top of a hollow paper towel tube. If you cut the tube lengthwise and roll it up really tightly, you can't stack anything on it. The tube will buckle, it'll bend out of the way, and the books will collapse. The same principle essentially works in column design, where we try to find shapes where the most or the highest percentage of material is out at the perimeter of the column. And it works in what came to be known as tube structures that Fazlur Khan, if he didn't exactly invent, certainly came some way toward perfecting in Chicago. By moving all of the structure out to the perimeter, you make the building work like a giant paper towel tube that can resist not only gravity, but can also resist bending forces from wind very efficiently. DeWitt Chestnut, a 40-story apartment tower, in some ways a successor to Commonwealth and to Esplanade. It's built by the Metropolitan Structures, the successor firm to Greenwald's, and it's on the same site as 860-880. It's just behind it. Bruce Graham, the architect, wanted to build skinnier and taller to avoid blocking views from 860-880. And Fazlur Khan's response was to develop a concrete tube structure where the skin is basically a bearing wall, but with hundreds of windows in it that relies on heavy reinforcement and some upstand spandrel beams to create stiff connections that make the building essentially work as four interconnected tube-like shear walls. There are other developments at the same time that begin to take concrete in similarly sophisticated directions. There's one project in particular, Lawless Gardens in Bronzeville, developed originally by an IIT grad, a Southside architect named John Matusami, who joins forces with a residential firm called Dubin Black to develop the scheme for another public-private partnership that is so successful that initially conceived of as two towers with some row houses. By the time it's under construction, there's clearly enough demand for a third. And these three towers sort of mark the Bronzeville skyline, but they're also very sophisticated exposed frames. They've taken the promontory formula and they have adapted it. They've refined it. The detailing on these goes beyond even what Mies was doing 20 years before. And in fact, these towers were awarded one of the gold medal by the AIA Chicago in 1970, beating out the John Hancock Center, which I think most people would recognize today over Lawless Gardens. But the detailing here, the conception of the concrete frame, its integration with the cladding was enough to convince the jurors that this project was the most important and the best project of the year in 1970 after they opened. Dubin Black and Matusami would go on to borrow the mullion frame idea and sort of make it their own. The lead architect John Dubin and his partners developed not only the rib cage as a structural ideal, but again, working with McHugh Construction, also developed ways of flying the forms so that they could speed construction and build these rib cage buildings faster than they could if they were in typical flat plate construction. Using steel formwork and using the so-called flying or jump forms, where you can take the formwork out of one floor, fly it up 3 more floors to start a new one. They were able to set records with these towers. The one second from the left, Lincoln Park West, this was built at a rate of 1 floor a day, which set a record for construction in Chicago. These were also phenomenally successful as development opportunities. They exist all over the city and at all kind of price points. So the one on the far left is a luxury development in the Gold Coast, but these also exist in neighborhoods like South Shore, in Uptown, and from everywhere from Lincoln Park to Bronzeville. The technique was so efficient, both in terms of time, but also in terms of material usage for the amount of structure that they needed, that this proved to be a remarkable, successful formula, almost no matter what the budget. Other things that happened in 1965, Chicago or Illinois passed this condominium legislation. It was one of the first states to do so. And this made buying a unit in a high rise much easier than the co-op system. And this too led to a kind of explosion in high rise construction, because condominiums, if you're a developer, they're much easier to kind of get in and get out instead of having to set up a corporation to run the co-op. So in the wake of 1965, Chicago sees a burst of concrete high rises that are aimed first at the luxury market. Condominiums are seen as something mostly for high end, but eventually these spread throughout the city. The Carlisle on the left is sold as the kind of most luxurious building in the city. Water Tower Place on the right is aimed at such a demographic that the Ritz Hotel opens on its middle floors, the first Ritz outside of Boston and New York in the United States. Architects take a variety of approaches to concrete slab construction. Some, like Hausner and Maxey, a firm that designed dozens of high rises throughout the city, think of concrete frame as the kind of generative element. And so you see in their work, the units are treated basically as boxes. Architects like Harry Weiss, who have sort of broader aesthetic agendas. Weiss in particular looks back to the 19th century skyscrapers with their bay windows. Weiss hides the concrete frame, lets it peek through occasionally. You can see the edges of the floor slabs supporting the bay windows. But otherwise, Weiss thinks that the concrete ought to get kind of covered or disguised by something a little bit more urbane, like brick. And concrete is also pushed to new heights. 1000 Lakeshore Plaza on the right is one of several buildings in Chicago that sets the record for high-rise height in concrete. Maybe the greatest of these, though, is Lake Point Tower, which is done in 1969 and which uses flat plate construction, again, to rise to an unprecedented height. It breaks the record that 1000 Lakeshore set, but it also takes Mies's formula of flat slab concrete, air conditioning at the perimeter, aluminum and glass curtain walls, and finds really new forms with it. Mies had proposed in 1922 a sort of curving skyscraper that a lot of critics have compared Lake Point Tower to. George Shipwright points out that this was originally supposed to be a four-lobed tower, and that to save construction costs, they simply cut one off. He claimed that any similarity to the Mies Tower was pure coincidence. But I think you can see in the construction photo both how concrete enabled a really simple construction, a very, very efficient construction. Again, you can see that the 9 or 10 inch flat plate allowing the maximum headroom and the minimum floor-to-floor height. At the same time, Shipwright and Heinrich realized that the flexibility of concrete formwork could lead to more interesting forms, voluptuous forms, in the case of Lake Point Tower. That, I think, has maybe been concrete's great legacy, in that we see concrete being used in a variety of ways. The flat plates that are expressed in Jeannie Gang's Aqua Tower, the flat plates that simply make for the rippling effect in St. Regis, Gang's latest skyscraper in Chicago. They also allow for great heights. 401 North Wabash, currently or at one point the record holder for concrete construction in Chicago, that uses outrigger trusses to support a skinny upper stories. And even today, 1000 or one Chicago on the right, using concrete to adapt the structure to a series of different programs, condominiums, apartments, but also retail and office space on the lower floors. Concrete in a steel city, even though both of the skyscraper books I've realized as Carol was introducing them, both focus on steel construction in what they show on the covers. These steel buildings went alongside many, many more concrete buildings. And I think one important thing to understand about Chicago's skyscrapers, but also skyscrapers in almost any city, is that the commercial high rises were often just a small fraction of of a city's total high-rise construction, and that residential construction, and especially concrete residential construction, very often filled out the bulk of the city's neighborhoods, but also usually outnumbered by far steel construction or commercial construction downtown. So with that, I'll call it a night. I think we maybe have time, Carol, for one or two questions that I'd be happy to take.
Well, I'm going to take a shot at talking, but first, let me say, Tom, that was really a tour de force. You packed so much information, but also showed, at least to New Yorkers' eyes, buildings that are at least half of them not really familiar to us. So it's really a testament to your holistic approach to the history of architecture, which includes not just technology, but the history of construction and the process of building, as well as the context of the more familiar architectural history that privileges the role of architects and the role of theory, or the influences from one generation to the next, or between the collaboration of architecture and engineers. No, there was an industry at the same time. It was also affected by politics, by the economics of the moment. And I think that it was clear to everybody who was listening how much you know about the history of Chicago, not just about the history of architecture, and how you bring the very important morality of Richard Daley into the picture as an influence. This is a way of looking at the history of architecture, which we should all aspire to. It seems to me. But what I'd really like you to do is to take some more credit in terms of talking about the years of research you spent and the process by which you are able to give us a grounding in history, as we've been discussing for these last several months, you and I, and in the context of the Modern Concrete Skyscrapers series, a hidden history, really the approaching the role of the material in the kind of evolution of the high rise is not anything that has been paid attention to, especially in these territories that you and I have discussed. Well, we don't really know what's underneath some of the New York skyscrapers, but you seem to have to know quite a lot about the process in Chicago. So tell us, how you got onto it, where you looked, how you followed the scent.
Yeah, sure. Well, some of it is just I've always felt that if I was curious about something, someone else somewhere must be too. So it's worth sort of chasing whatever whatever comes up that seems interesting, right? The really fascinating thing to me was that if you were to do just an architectural history of Chicago high-rises, there's a fairly well-traveled path, and there are sources that sort of everyone knows. But these buildings show up in all sorts of other places. They show up in the real estate press. They show up in the contracting press or the engineering press. There turned out to be just a tremendous amount out there that wasn't in architectural record or progressive architecture, that these buildings were of interest to overlapping disciplines, and also to groups that you might not have thought of. A lot of the research that I ended up doing was on the real estate and how the skyscraper really fit into the development of Chicago's real estate community. So there's just a ton of information out there that was what I would call non-traditional, and not all of it gets woven in, not all of it coheres as a narrative, but enough of it kind of opens up doors that you start to see buildings in different ways, and you start to be able to literally crack them open in the case of the student models, where we're trying to get in and dissect the kind of literal anatomy. But also in things like understanding what condominium legislation does to a real estate market, and why that leads in some cases to subtly different buildings, subtly different approaches, based not on anything technical, but based instead on the kind of financial context. And I think you can do that for politics, you can do it for technology, for industry, for all sorts of things. Seeing the skyscraper in the sort of center of a Venn diagram that kind of keeps unfolding. So you're right. It's a painstaking process because there are so many overlapping disciplines that come into it. But it's an enjoyable one too. It's not years and years of like high level math problems. It's years and years of like finding stuff out. So and you summed up very clearly the kind of hope for this book and for the other ones is to try to understand these things as not just kind of idle objects, but really as almost like a kind of fossil record of all sorts of things that are going on at the time, but also through the lifetimes of these buildings.
So we are at 7:00, and that seems a very good place to end. Let me just mention to everybody, really, you should get this book. It's a great Christmas present for yourself or for somebody who loves architecture or loves the city of Chicago. And it's a bargain at $45. So take advantage. It's wonderful that Tom has given this series of cross sections through the book and featuring residential, which is something that we don't give enough attention to in the history of high rise for sure. But I think you've really clearly demonstrated that Chicago, like New York, is a high-rise city. And in order to really understand it, you can't just look at the office buildings, and you certainly can't just look at steel. So thanks, Tom, for being with us, and thanks everybody else for being with us tonight. See you next time.
Yeah, thanks. Thank you, Carol.